In the name of God. My name is Reyhaneh Dehghan. I've studied Bachelor of Science in Computer Engineering at Persian Gulf University. I'm studying Master of Science in Computer Engineering at Shamran University. The subject of my article is the detection of Parkinson's disease using convolutional neural networks and data augmentation with SPECT images. Introduction. Parkinson's disease or PD is the second leading nerve cell disease after Alzheimer's disease, affecting mainly the neurons which produce dopamine substance in the substantia nigra inside the brain. Dopamine is important in adjusting the moves of humans, and its reduction can be the cause of many of the symptoms of a person with PD. In addition to moving symptoms, a PD patient may also have non-moving symptoms. About 60,000 people in the United States and about 7 to 10 million people are diagnosed with Parkinson's disease each year. The absence of dopamine substance is seen in 2 to 3% of the people with 65 years old and higher. Related work. In addition to clinical diagnosis methods, machine learning methods have been also used during the past 2 decades for diagnosis of diseases. Deep neural networks are currently the latest models of machine learning in many fields, including image processing algorithms and medical detections. For example, the authors used convolutional neural network with the VGG16 architecture on SPECT images and achieved 95.2% accuracy. And the others used to CNN with the AlexNet and LeNet architectures and performed their experiments on SPECT images and achieved 95.1% accuracy. And the others used the convolutional neural network with the AlexNet architecture and examined the results of their experiments on MRI images and reached 88.9% accuracy. Proposed method. This figure shows the proposed method in this paper for detection of PD and classification to 2 classes of normal and patient. This model consists of 3 main phases: data pre-processing, training, and test or evaluation. The SPECT images were subjected to 2 pre-processing steps in this study before being used. Number one, image resizing and normalization. In addition, data augmentation is also considered on the training subset. Image augmentation is the process of expanding the training dataset by using transformations such as random rotations. This helps us to create a larger training dataset and consequently enables our model to converge more quickly. In this article, the rotation range function is used to increase the data. The data set used in this article contains 650 SPECT images, which are divided into two classes. Number one, health, number two, patient. 650 SPECT images were investigated in this study taken from the PPMI database. The PPMI database is used worldwide by the researchers to identify symptoms people with PD. The dataset is also divided to three subsets: train, validation, and test, with a share of 80%, 10%, and 10% respectively. Proposed method. In this study, we use the CNN architecture, which is usually composed of several layers, as the input, convolutional, pooling, fully connected, dropout, and a final output layer. The architecture proposed in this paper consists of 12 layers, which consist of 5 convolutional layers with the ReLU activation function and 3 max pooling layers, 1 flattened layer, and 3 fully connected layers. In the first layer, 64 convolution filters with kernel size 7.7 and stride 2.2 with ReLU activation function. In the second layer, 64 convolution filters with kernel size 3.3 and stride 1.1 with ReLU activation function. In the third, fifth, and seventh layers, 128 convolution filters with kernel size 3.3 and stride 1.1 with ReLU activation function. In the fourth, sixth, and eighth layers, max pooling with pool size 2.2 and stride 2.2. For classification, 3 fully connected layers are applied after the convolutional layers. The last layer uses a fully connected layer with a neuron and a sigmoid activation function. In this study, the autograph optimizer with 0.01 learning rate and binary cross entropy cost function has been used. A batch size of 32 and an epoch value of 100 were used for the training phase in simulation experiments. Results. The evaluation criteria of accuracy, specificity, recall, awareness score, coherence kappa have been investigated. Table 2 shows the results of evaluation criteria for the proposed method on the dataset. As can be seen from the table, the highest value is related to the recall criterion of the proposed model with data augmentation techniques. Despite we expected much better results with data augmentation, the results show very few improvements by using this technique. Figures 7 and 8 show the performance evaluation of the proposed method with data augmentation techniques and without data augmentation techniques according to accuracy and loss function in the training and validation phase. The loss function diagram of the proposed model has less oscillation and convergence using the data augmentation technique, and there is no sign of overfitting and underfitting. Conclusion. At the end of this section, Table 3 shows a comparison of the proposed method with other studies on the same dataset. As can be seen from this table, the accuracy of the proposed method with data augmentation technique is greater than the methods presented in Table 3. As future work, it is suggested to use the GAN to produce a similar image, and the GradCam or GradCam++ method to interpret the decisions model by the proposed deep learning model. These are the references. Thank you for your attention.